Okay, do you have any on-camera comments for before the competition?
Don't look, it's too awesome, it'll break your camera. We are adding the finishing touches.
Okay.
Aesthetics. Our
Yeah.
car is going to be the flaming one. You should be able to tell.
Right, I hope not literally.
Hopefully.
Yeah.
Although that would be really cool.
It would make an impression. It's all right.
So just look for us in the winner's room.
Okay.
That will be it.
It's probably something cool.
No, they aren't. That's why I'm doing them tight. So they won't like break their wheels.
All right, y'all ready? Are we ready?
Working on it.
Oh, you're still working on it?
Well, we're just putting our battery back in.
Oh, okay.
You lost one of your weapons.
Leave it off.
Are we putting that little case?
No, he said leave it off.
Hey, hold it up a second.
All right.
Rub those engines.
You let me know when to hit the start button and then you make sure.
Is that alright like that?
All right. You tell me when to hit the start button and then we'll count. Okay.
I know what you mean. It's finally calm down.
1, 2, 3, 4, go. All right. There we go, 24. All right.
You're nervous, man?
Yeah, I mean, first of all, tell me when they actually cross the finish line. Swing around to 19. Are we going to
I'm taping the scores just in case I totally botch it.
Was that hard? Yeah, that was hard.
I'll see you later. Oh, you're good. See ya.
And this is November 18th, 2010. And this is Mr. Stabler here to visit with us for the
Andrew, our car is destroyed.
It's still moving. Oh, there's the bitter. Oh, there's the back.
He's dragging the battery. Rick, take off the battery of that.
We're in
Until our battery's heating up.
No, it's kind of poking.
This is what engineers love to do best.
More and more.
pilots, one of those Japanese pilots. Come on, help me.
The kamikazes?
There we go. The tape is holding it.
The tape is holding it together.
Oh, we got him hooked. Got him hooked by the lawyer. Drag him around.
His wire?
You got him.
Yeah, they got him. I got it.
All right, these are freshman design presentations.
Are you enjoying yourself?
Yes.
Can you do a spin? Can you do a spin out? There we go. Okay.
Oh, you gonna file this?
Take your water bottle out there.
We got
Oh, you left it?
There's one of this. It's in the spirit.
Okay, this is Team 2, Section 35. All right, go ahead.
Engineering 1110, final design report, intro to electrical engineering. Our final design project was a Lego vehicle race, or Super Lego Kart Design, by Mark Bowman, Timothy Dunlap, Micah Hayes, Joshua Lambert, and I'm Della Stabler.
As she said, our final design project was to design a wirelessly driven Lego car that could pass through specific gates and push a Lego block across the finish line in the shortest amount of time possible. The limitations were the car had to be made out of Legos or Lego Technics, and the only other parts that we could use were an RC receiver, a motor control board, connectors, wire, batteries, an on and off switch, and 2 motors. And in addition to that, it could only have a maximum of 10 volts as a supply voltage, and it had to be easily measurable before the actual race. After hearing these guidelines, we decided that we wanted to try to optimize every component that we possibly could, and in an attempt at that, we tried to make a car that was very easy, was very maneuverable, and had good balance and good torque for the block, could accomplish minimal time for the actual course, and was light in design, and could have the maximum output voltage possible through the 9-volt batteries that we used that had to be easily attachable to the actual car. And in order to accomplish these optimizations, we tried to do most of our focusing on the supply voltage, the power supply, wheels and gears, drive strategy, course path, and body design. Here is our original design. It didn't quite turn out that way, but we're quite happy with our product. But we'll get to that a little bit later.
So I'm Mark Bowman, and I'll be covering course path. So we had to decide whether skipping any obstacle in the course would be beneficial.
Our final design used a variable resistor to get an output of exactly 10 volts from our 2 9-volt batteries, which had the best connection, because we could purchase connectors that would do that easily. Our wheels were about 1 inch in diameter and also about 1 inch wide, which gave us great traction, particularly when they were clean. So we were able to push the block relatively easily. However, we did sacrifice some speed on this. We had great turning radius. Didn't necessarily help us on the course, but it looked pretty cool. And the reason for this was partially because of our rear support. Our rear support was a single swivel wheel that really minimized friction. We played around with a lot of different designs, probably spent the most time on this single element, and this one worked out the best. For our driving, we hooked up 1 motor to each wheel. And like I said, the combination of this made it where our car could literally turn on a dime. For the course, we chose to traverse the entire course in its entirety. The gates and the block all together gave us absolutely the best possible chance at getting an optimal time. The body of our car was constructed out of Technics. It took us a little bit longer to construct than it would have out of Legos, but it was more durable and a lot stronger and flexible. When we had to use regular Lego pieces, we used the pieces that had the holes in them so that we would minimize our weight and hopefully increase our speed. All this together resulted in, on competition day, our final time being 14 seconds. The best time for the course was 11 seconds, so we weren't too far off of it. And as we reevaluated, our car, we felt, was equal to the challenges and equal to the other vehicles at the competition, except maybe in the area of wheel size. And if we could improve our vehicle, we would increase the wheel size, and we feel like that would increase our speed. Probably the most valuable thing that we did on the, for the competition was to design our own course. Driver practice turned out to be a very big factor in how well we performed on competition day. So except for the one criteria of wheel size, our car performed to specifications, it performed the way we expected it to, and was fully able to complete the course. Thanks.